Hello everyone, in this video we'll see how a photoresistor works. To do that, I'm going to take a breadboard, take a 9-volt battery, and of course in the Tinkercad software, right? Okay, so to make our circuit look compact, I have changed the orientation of battery. Now I'm going to take an LED and I'm going to I'm going to rotate it so that the anode is the front followed by the cathode. Then I'm taking a photoresistor. Okay, so photoresistor is a sensor which senses the light, and as per the light the resistance value changes. Okay, now here I'm connecting the positive supply of the battery to the breadboard as well as the negative to the breadboard. Now I'm looking for a switch. Okay, so switches to once I start simulation, only if I start the switch or to turn on the switch I can simulate the circuit. So to make it a little understandable, I have taken a switch, right? So the first terminal has been grounded and the last one is given positive supply, and the second one is the signal that the wire that is connected to the photoresistor, right? Then from the other end of the photoresistor I'm connecting it to the LED, and the cathode of the LED is connected to ground. Okay, so our connection is done. Now all we have to do is turn on the simulation and turn on the switch and see what happens with the photoresistor and LED, right? Okay, I started the simulation. There won't be any change because I haven't turned on the circuit. Now that I have turned on the circuit, you can see the LED glowing, right? Observe it. You can see the LED glowing. It's not glowing now. Okay, so the reason is because I have turned on the circuit, so power from the battery falls. Okay, so once you click this photoresistor, you can see a tab at the top where initially it will be in the dark, and we can move it towards the bright area, right? So to move it we have to hover over it. You have to drag over it, not hover, right? So if you see, I'm dragging over, so the resistance values is getting decreased. So once the value of resistance decreases, the power or the voltage, the current flowing to the LED will increase. As a result, the brightness of the LED will increase, right? So I'm going to increase it further, increasing further and to the maximum, right? So doing this we will learn, or we can understand that the help of light the photoresistor works. Now to give another small example, the role of capacitor, let's connect a capacitor to the circuit. I'm going to connect it serially, right? Okay, now observe what happens to the LED. I'm starting the simulation. Once I turn on the switch, the LED starts, it glows and immediately it turns off, right? I'm going to simulate it again. Observe the LED. Okay, the switch is off actually, so be very careful with that. Starting the simulation, turning on the switch. Okay, the LED is glow. It glows for a second or less than a second, and then it turns off. The reason is because the supply that we are giving is a DC voltage, right? So capacitor will charge for the first phase and it will discharge. After that it will not be charged. No matter how many times you turn on the switch and turn off the switch, the capacitor again will not get charged. Only thing you have to do is you like to restart the simulation, which actually in practical life is not possible, right? So this is how capacitor influences in a DC powered circuit, right? This is completely different if you connect the capacitor parallel, right? Since in parallel the power will travel through photoresistor, it will also travel through capacitor of course, but since we have a parallel connection, photoresistor will be considered, right? Okay, thank you.